Hello, I'm Emre Erdal. I'm a fourth-year computer science student in Bilkent University. Today, I will introduce a topic from Bioinformatics class. The topic is the brute force solution in a motif finding problem. Before talking about the brute force solution, firstly, what is motif finding problem? The motif finding problem is done in the sample DNA sequences, and it is like finding the pattern that is implanted in each sequence, and this is named as motif. And the motifs can have like different lengths, and through them we can analyze the brute force solution. And to analyze the motif finding problem more, here in the first example, there are no mutations as exact match in the motifs are provided. For example, it is ACGT, and all of the other five ones are the same. So for all of the sequences, there are like exact matches. And for the second example, the patterns have two mutations and they are labeled as red. And through them, the exact match and the mutations can be analyzed. And what is consensus? Here, like the consensus can be found by a strategy, like it is by looking at how many A's are there in the first column and how many C's or I mean G's in the second column, and write the number and take the like the char with the highest number. So it is A for the first one, C for the second one, G for the third one, and it continues like that. But compared with other ones, we should choose the best one, and through the brute force algorithm, we can choose the best one by comparing all of the possible consensus and possible motifs that can be found. So there are some mathematical calculations for them, and the brute force solution. The brute force solution is for the motif finding problem, and by determining the best profile and consensus pattern, uh, it does the job. And how made like how can you find the best profile? It can find it by maximizing the score for various starting positions. And it is the code segment for the brute force motif search algorithm, and it is the question that I will present detailedly. And to analyze the algorithm, the best score is assigned to 0 at the first stage, and for looking at all of the sequences from the beginning to the end, like if the score is higher than the best score, then the best score is that score to compare it at the next stages, and the best motif is assigned accordingly, and it returns the best motif when the for loop ends. So I will introduce it shortly in the slide, and I will introduce them detailedly in the next slides. For example, at the first stage, we are finding the best motif with size 2. So at the first stage, it is AT, the first one. The second sequence is CA. The third is AT, and the fourth is starting from GA. And initially, it is like that, and it goes from GA to AA at fourth sequence, and then AT, and it returns back to GA, and for the third sequence, like goes from AT to TG and continues like that. So it compares like for all of the sequences, and so it has like larger complexity, and it will be discussed detailedly in the further parts. So for the solution initial case, at the initial case, as I mentioned, all of them are starting from the zeroth index. So like it is AT, CA, AT, and GA. Firstly, And as the best score is assigned to zero at zero initially, and when the score is higher than the best score, the new best score is two in the initial stage. In the first comparison, I mean, it has changed to two, and like best motif can be found as 80. And then by the for loop logic, it continues like that. And as I mentioned, after that, the GA turns to AA, and ATCA and AT in the first, second, and third sequences remain same, and it is compared, and the best score not changed. And also at the last point here, it goes to 80, the fourth sequence, and then as the sequence is like ATCA, AT, and AT, like the best score is 3, as there are 3 ATs, and the best motif is AT by this formula. We can continue by assigning the best score to 3. Then as we like finish the last row, now we can move to the third. So in the when we analyze the third sequence, initially we like analyze ATCA 80 cases. So now we are starting with ATCA, TG, and then GA. So like when GA is changed from AA or AT, the best score does not change, so the motif does not change, the best motif. Like similarly, it continues by changing TG to GC, and the best score does not change in either cases when we change GA to AA and AT also. So it remains like that in this stage. So when we go to the second sequence, we initially analyze the CA possibilities, and now we are moving to 81. And here, initially we have 80, 80, 80, and GA, as all of them are starting from 0, and it starts from, and the second second sequence is starting from the first index, and by changing GA to AA and AT, it is analyzed. So here we have 80, 80, 80, and 80, where in the first sequence it starts from 0, where the second it starts from 1, and third 0, and in the fourth sequence it starts from the third index. I mean second index. So when we find 80, 80, 80, 80, the score is higher than the best score. The best score was 3, and now the score is 4. So the new best score is 4, and the best motif is 80 by this formula. So it continues by changing 80 to T, G, and GC, and repeating the changing of GA to AA and 80, and it repeats by like making these steps available for changing 80 to TG in the like second sequence, and the best score does not change from it. And now we analyze all the possibilities when the first sequence is starting from the 0th index, and the second is starting from all third, fourth. We analyze all of them, and now we should look the TA and AC stages for the first sequence, and let us look for all of them as mentioned by the for loop logic that is mentioned. So the process is repeated for TA and AC, and the best score does not change. So here, as always, the score is lower than the best score. The best score does not change, and the best motif does not change also. So for this example, the best motif is 80, and for this best motif, the best score is 4 by finding the 80s in all of the 4 sequences. In the left part, you can see the code, and in the right side you can see like the complexity. For this complexity OLN over T, the T is the number of sample sequences. What is the number of sample sequences? It is 4 because we have 4 sequences starting from by A, C, A, and G, and N is length of the sequences. ATAC has 4 lengths, so either all of the sequences have 4 length, so it is 4 also. And the length of the motif, is mentioned as 2 in the initial stage, so it is 2. And the complexity can be found by OLN over T for all of this, because for each starting position the scoring function makes L operations. So this is the complexity for this problem. Thank you for listening me. Uh, I'm uh, I'm waiting for your likes to the video, and I'm waiting for your comments. Thank you.